All right, in this question, we're asked to determine if the system is inconsistent or dependent, which tells us that there's not just one triplet answer. Like a lot of times, you'll just be looking for one ordered triplet. I'm just, X comma Y comma Z, where you have an actual number for each one of those. And it works when you plug it into all three of them. But this is not one of those cases where we have one solution. This is a case where the system either has no solution or has infinitely many solutions. So inconsistent would mean no solution. Nothing can make all three of the equations true at once. There's no one ordered triplet that would work for all of the equations. And dependent would mean that we have infinitely many options because actually they're all really the same plane. So what we can do is just start solving this like we normally would. And if we get to a point where we have just numbers involved and we get a true statement, then let's see, no solution. Let me say it like this. No solution will happen when you have, where it does, okay, inconsistent is the same thing as no solution. And the way we can tell is when we solve, if we get all variables cancel out, or I should just say disappear maybe. Okay, so all of the variables, the x, the y, and the z are gone. And then we have a false statement with numbers that are not equal to each other. Okay, if it is dependent, that means infinitely many solutions. And what will happen is all the variables will disappear. Okay, but we get a true statement. Okay, so that's what we're working towards. We just want to see what happens when we try to solve this. We know that since there is not just one solution that's going to work for all the lines or all the equations, then it's either going to be one of these two things. So we just need to try to solve it like we normally would and see what happens. Okay, let me pause. Okay, so what we've learned in other examples is to try to eliminate one variable and come up with two equations that only have two variables in it. But we already have one equation that has only the two variables x and z. So we just could take these other two and come up with a fourth equation that has only x and z in it. Okay, so we'll take the first equation. So this is equation 1, equation 2, equation 3, right? So we're going to take the equation 1 and we're going to just rewrite it. 2x minus 3y, that's a y, 3y minus 9z equals 15. And then we'll take the third equation, negative 3x plus y minus 4z equals 23. And then we're going to try to eliminate the y because we want to end up with a fourth equation that does not have any y in it. It only has x and z. So how are we going to eliminate y here? Let's multiply the bottom equation by positive 3. That way we will end up with a positive 3 coefficient on the y term, and that will help the y's cancel out. So now what I'm going to do is I'm actually going to back up here, and I'm just going to rewrite equation 1 as it is, but I'm going to rewrite equation 2 with having been already multiplied through by positive 3. So I'm going to write down 3 times equation 3, and that's going to give me negative 9x because I'm multiplying 3 right here. So that gave me negative 9x, then 3 right here is going to give me positive 3y, and then 3 right here is going to give me negative 12z, and 3 here, don't forget to do it on your constant, that's 69. Okay, so now that I've got that done, I can see that when I add these two equations together, my y's cancel out. So then I have 2x minus 9x leaves negative 7x, and negative 9z and negative 12z leaves negative 21z, and 15 plus 69 is going to give us 84. All right, so now that we have two equations with only x and z, we can use those together to eliminate another variable. Okay, so now I have a fourth equation. Okay, and I'm going to just use that along with my second equation to eliminate another variable. So let's write down the second equation is x plus 3z equals negative 12. And the fourth equation, which is negative 7x minus 21z equals 84. And if I multiply the top equation by 7, then my x term will cancel out and also my z term will cancel out. And that means that all the variables will disappear and I will end up with a statement that has only numbers in it. So we knew that was going to happen because remember we knew it was either going to be inconsistent or dependent. So we already expected that all the variables were going to cancel out just by the little hint there in the way they told us to do this problem. All right, so multiplying equation 2 by 3 gives me 3x and 9. Wait a second. That's not what I meant to do. Let me back up. We're going to multiply equation 2 times positive 7. So that'll give me 7x, 21z. And then what's 7 times 12? 70 and 14 is negative 84. So this is really good because now my x's cancel, my z's cancel. So on the left, I just have 0. And then also my constants even cancel to 0. So this is a true statement, meaning that this is a dependent system, right, with infinitely many solutions. Now, notice that part B says if your answer is dependent, which it was here, then find the complete solution and write it as a function of t, right? All your unknowns, right? Everything is a function of t. Okay, so where z is t. Okay, so I'm reading z is t, right? So now, instead of writing just a solution that is x comma y comma z, I'm going to change the z to a t, and then I'm going to write my x and my y in terms of t. All right. So, okay, what we're going to do is we're going to use first the second equation, and let me write it down. My second equation, which is just x plus 3z equals negative 12. X plus 3z equals negative 12. And we're going to solve for x and replace, first of all, let's replace the z with t since now we know we're going to be using t instead of z. Why? I don't know. It's a weird question, but it's okay. So we replace the z with t. Then we're going to solve for x. So we're going to subtract 3t on both sides. So we get x is equal to negative 12 minus 3t. Okay, now that I have an expression for x, I can write that up here in my ordered triplet. So I'm going to write that for my x term. I'm going to write x equals negative 12 minus 3t. So I'm going to write that right here, negative 12 minus 3t. It could also be written negative 3t minus 12. Either one is fine. They mean the same thing. Okay, and then I have my comma here. Negative 3, what did I say again? I messed it up. Negative 12 minus 3t or minus 3t minus 12. Okay, so now I've got the x part. Now I need the y. Okay, so I need to take one of my other equations that have y in them and solve for y, and then replace the variables with the other expressions we have for each one of them. So let's take negative 3x plus y minus 4z, because y is all by itself, that's why I chose it. I don't have to divide by anything. I'm going to just be able to solve for y by moving the other terms to the opposite side of the equals. So that simplifies my process. So I'm going to use this one, equation 3. So let's duplicate this. Actually, no, we're just going to keep going down like this. Okay, so the third equation, which is negative 3x plus y minus 4z equals 23. And I'm going to solve for y. So I'm just going to add 3x to both sides, and I'm going to add 4z to both sides. So ultimately I get that y is equal to 23 minus x and minus, I'm sorry, that is wrong, is can be. Why did I say that? I'm adding 3x to both sides. So that's 23 plus 3x and 23 plus 3x plus 4z because I'm adding 4z to both sides. There we go. All right, now what can I do? I can replace the x here. Okay, so I'm just rewriting everything else, but I'm replacing the x with this equivalent term 3 or expression negative 3t minus 12. And let's simplify that. So we have y equals 23 plus 3 times negative 3 is negative 9t. Okay. And then 3 times negative 12 is negative 36. And then I'll bring down the positive 4z. And then let's continue to combine like terms here. So y equals, what is 23? 36 minus 23 is 13, and 36 is the larger number, so we're going to keep it negative. Negative 13, and also let's replace this z with a t, so we can combine like terms here, because remember z and t are the same thing. So I have negative 9t and positive 4t leaves negative 5t. Okay, so now I have an expression for y, and that will go up here in my ordered triplet, negative 5t minus 13. Okay, so I'm going to write that up in here. Negative 5. I'll write it in red so it matches what we just did. I feel like I want to write all of this over again because it looks a little messy. So for x, we had negative 3t minus 12. Then for y, we had negative 13 minus 5t or minus 5t minus 13. And for z, we have just t. So this right here should be our final answer. Okay, and I just paused it to double check, and then yep, that is it. That is our final solution for this problem.